Hello, you're watching TelecomTV and our special series on defining 6G networks. I'm Guy Daniels, and in this panel discussion we will be looking at the next steps towards the standardization and commercialization of 6G. We are publishing a series of reports on defining 6G networks, building on the key takeaways from the recent 3GPP workshop, and we aim to dive deeper into some of those important themes today. And I'm delighted to say that joining me on the programme are Puneet Jain, who is Senior Director of Technical Standards at Intel and the 3GPP TSG SA Chair, Diana Pani, who is VP and Head of Wireless Standards at InterDigital and also the 3GPP RAN 2 Chair. Luke Ibbetson, Board Director for NGMN and Head of Group R&D at Vodafone. And Dean Bubley, Founder and Director of Disruptive Analysis. Hello everyone, it's good to see you all. Thanks so much for taking part today. Now we're going to be focusing on the outcomes from the 6G workshop, the findings from our Defining 6G Network series, and also looking ahead to the next steps in the development of 6G. So a quick background first. Puneet, you chaired the workshop. What was the context and purpose of the event, and were you surprised by the amount of submissions?
Yeah, thank you very much, Guy, for this opportunity, and it's my pleasure to be here. So 3GPP 6G workshop was held on March 10th and 11th in Incheon, Seoul, Korea. And it marked a pivotal moment in shaping the path towards 6G within the global standards ecosystem. This workshop was designed specifically for 3GPP members company to present their vision and priorities for next generation technologies, including radio interface, system architecture, core networks, and protocols. The scale of participation itself speaks volume. We had around 1,600 registrations with nearly 800 attendees physically present in the workshop, which underscores the global interest and urgency around 6G. In terms of contribution, we had 219 inputs received from a diverse group that includes mobile network operators, vendors, academia, and 3GPP market representative partners. The workshop was structured in 3 distinct tracks to reflect the multifaceted nature of 6G development. First, we had a joint session which focused on system-wide aspects and gave priority to the contribution from operators and MRPs. Then 2 parallel tracks ran in parallel, the RAN sessions, which focus on next generation core technologies, and there was also an SA and CT session, which covered system architecture, core networks, and protocol evolution. This workshop built directly on the momentum from last year 3GPP workshop on IMT 2030 use cases, which aim to align 3GPP with regional and global research activities in terms of 6G use cases. While the earlier event concentrated on 6G use cases, the March workshop was a natural next step, allowing the entire 3GPP ecosystem to articulate their vision and expectations for 6G technologies. In essence, it served as a platform for setting the technology wish list that would feed into the various working groups within 3GPP in terms of defining a 6G study starting with release 20. And that's the work which we're going to be starting from the June meeting onwards.
Thanks very much, Puneet, for that overview. As you say, it's a start, or it's near the start. We had the case study workshop last year, but we're starting to get into the serious business of preparing now for standardization. Dean, I want to come across to you because let's face it, there's a lot of interest in cellular standards, always has been. It's no different this time around, and the timing often seems very early. But it's essential to get things right. What's your take from talking to your clients and partners, and you're observing this industry from where you sit? What's your view of what's happened so far, and what have you been seeing as a result of this workshop?
So just a bit of context here. So as an industry analyst and commentator, I sort of followed the evolution of multiple generations of wireless, not just cellular, but also other technologies as well. And I'm also one of the conveners of a group called 6G Reset, which aims to try to make 6G oriented towards what we term maximum usefulness. Because we looked at what went wrong with 5G, where the attention went, why some of the things that were promised weren't delivered, and also sort of what the broader technology world will look like when 6G emerges. And I think that what I'm seeing at the moment is actually some sort of fairly welcome pivoting from some of the earlier sort of more fanciful like use cases and technology concepts for 6G towards something which does look actually a bit more useful. So there's probably less emphasis on some of the technology elements I'm seeing, like sub-terahertz and RIS and some of that. I think there's a little bit more humility about the ability of 6G to define the future of AI or robotics or edge computing, when all of those things already exist and will have had another 4 or 5 iterations by 2030 on their own. But I also still think that there's some missing parts. And I wasn't at the Seoul workshop, but I've sort of been at Etsy and other events subsequently on 6G. And the sense I get is that it's still a little bit too operator centric, which is understandable. But I think it's something that I'm a big advocate for, what I call business model neutrality. And I also think that there is still a bit of a risk of the industry talking to itself too much, although there are more participants from other industries. I hate using the term verticals to refer to the 98% of the world's economy, which isn't telecoms. But I'll leave it there. But I think it's sort of the supertanker's starting to edge in the right direction from my perspective.
That's almost an endorsement, Dean, from you. That's terrific. Yeah, well, like you, we've seen a number of generations in our time come and go. It's a fascinating process. I'd like, though, to pick up on some of the points that we've identified from the workshop submissions. They may not be the most important points, but we think they're quite important. And I've got a list of a few here. I just want to go through with you. And top of my list actually speaks to what Dean was just saying there about learning from 5G. This really came out of a number of submissions. Learn from 5G, keep things simple and focused, and make sure important capabilities are available from day one. Luke, can I come across to you first on this one? How important is this, and how might it shape the outcomes of 6G?
So I'll go. Well, by the way, great to be here, and I'm very glad to be joining my fellow panelists. I think this is a very well-timed debate. So I would go further than saying that we need to be learning lessons from 5G. We should be building on 5G as the default connectivity fabric for everything that we consider 6G might be in the future. So I think 6G has quite a high bar in terms of proving its worth beyond what we're already building. And I think if you look at the output from the workshop in terms of emphasis on simplifying network build, making sure that we can provide continuity of services from day one, we can provide native voice, we can provide the right reliability for customers. I think that speaks to the 5G NR being something that we would naturally be looking to build on as we go into the 6G era. So if you look at what NGMN is doing in terms of building frameworks against which we can assess any meaningful advances in radio interface technology, we will always pull it back to what we can be doing using today's technology or a close evolution of this. But I very much support the need for network simplification, reducing total cost of ownership as we go forward, and reducing absolute energy consumption. Those are some of the key principles that we have within NGMN 2.
Great, thanks for those perspectives, Luke. I'm going to come across to Puneet again in a moment, but Diana, I'd like to introduce you to the debate now and get your views, and you follow up on what Luke was saying there, and some of the takeaways from the submissions that we do need to learn from what we did last time.
Thank you, Guy, for having me in this very good panel with very good candidates. The one thing I wanted to say is that, this message of keeping it simple, I think it speaks to when we developed 5G. I think the one thing is we wanted to make a very, very flexible system and develop it in a very short time. And to do this, we ended up introducing a lot of optionality, a lot of options to even address similar concerns and problems. And because of this, it made implementations complex. It made deployment it made deployability very difficult. And this is where I think we need to learn from our 5G mistakes. And when we're looking at designing 6G, I think we need to really take into account what are the key design targets that are important for the whole industry, prioritize amongst them, identify solutions that are implementable, evaluate them properly. I think this is key. Have the time to evaluate them properly, which we didn't have in 5G because the timeline was very, very short. And once we evaluate them properly, pick something that's addressing the design targets, and is implementable. And this is very key, we need to have the courage as a group to make decisions, not put every option that's possible to make everybody happy, and make some of these features mandatory, actually. And we need to make some of these features or solutions that we decide mandatory to guarantee performance requirements, to guarantee that the operators are getting what they wanted. So I think these are very important lessons that I think we can take from 5G and do better in 6G, but it takes also a mindset change from everybody in the industry. So I hope we can all do this together.
Yeah, thanks very much, Diana. And this question of optionality really did jump out of some of those submissions last month. I'll come back to Dean in a moment, but Puneet, let's come to you, because let's face it, you were there, you were chairing. Was this one of the major themes that came out?
Yeah, thank you. The key takeaway from the 6G workshop submission was clear need to apply the learnings from 5G, especially the importance of keeping 6G simple, focused, and ensuring that essential capabilities are available from day one. One of the major challenges with 5G was the complex migration from non-standalone to standalone architecture. This was compounded by excessive number of architectural options, features, and configuration, like what Diana also mentioned. And some features in 5G, like network slicing, saw slow and uneven adoption, not due to lack of need, but due to the implementation complexity. So for 6G, we must approach design and standardization differently. The focus should be on streamlining well-dimensioned set of core functionalities, deliberately avoiding redundant or over-flexible options that complicate the integration and operations. Simpler, more coherent architecture can lead to total cost of reduction, and when combined with AI native automation and optimization, can drastically reduce operation overhead and enhance adaptability. So this should be one of the things which we should drive more efficiently within 6G standardization. And another major differentiation on 6G must be that security, integrity, and privacy are embedded from day one. So these capabilities should not be bolted on later and must be built into the architecture from the start. So I think these are some of the learnings which we see from the workshop.
Great, thanks so much for those insights, Puneet. I'm going to come back to Luke, but Dean, let's go across to you first. This whole issue of learning from 5G.
I think it sounds like we're taking on board some of the problems with the 5G era, but I think there's others that we're not necessarily being honest with ourselves sometimes. I think there's still, from what I hear, too much of an assumption that 3GPP is always going to be center of the universe. Luke, for example, mentioned the outdoor and indoor connectivity and whether we can have various hybrids. And quite possibly we can, but we shouldn't be assuming that a 3GPP core is always the sort of top level, or the sort of, if you like, has administrator rights. In some cases, it could be an industrial system, it could be a Wi-Fi network, it could be a fixed network, which, if you like, is the top layer, and the cellular side is the secondary. And so we need to think in terms of bidirectionality, and that as well as sort of 3GPP trying to control a Wi-Fi network, it should be possible for a Wi-Fi controller to control, let's call it 6G native radio. and the same thing for satellite and for industrial IT systems as well. The other side, which I'm not seeing at the moment, is the sort of the tension between the optionality for industry specific or use case specific variants of 5G and what gets standardized and what doesn't. And so, one of the things I'm wondering is whether there is perhaps a mandatory core standard set, but then there's like delegated authority to, let's say, the automotive industry or the AR VR, if you think that's going to be important, or industrial side of it, and almost like let those groups of and communities of interest, you call them market representation groups, develop their own almost like plug-in standards, so they've actually got more of a chance of adoption without necessarily being looked at just through the lens of, say, traditional mobile operators, but actually a more enterprise-centric, for example. And I think that bringing up the business model neutrality of 6G, so that yes, you can have MNOs, or you can have government, or you can have enterprises, or you can have shared networks or wholesale networks, all on an equal footing, I think is still a little bit absent.
Yeah, thanks, Dean. Very interesting ideas and areas there that we certainly need to pick up on later. Luke, I'm going to come across to you because you wanted to come in with a comment as well.
Thank you, Guy. It was just a very quick response back to Puneet when we were talking about the need for 6G from the outset to have the right degree of security and resilience, which of course I agree with. I just wanted to say, for the avoidance of doubt, we don't consider what we're deploying in 5GSA to be in any way insecure, as in we're not waiting for the arrival of some undefined 6G network to fix a security flaw in the way that we're deploying networks. So if there is a perception that one of the motivations of 6G is because we need it to be more resilient than we have today, I think that's quite a difficult case to prove.
Yeah, thanks very much, Luke. And Luke, can I just come straight back to you, because I know you do work on quantum and you're heavily involved there. Is there a linkage there with 6G as well?
I think there's a linkage with the era of 6G. As we talk about the next few years, we will have to systematically update the cryptography used within a multitude of systems, including those used by the telecoms industry. So this transformation needs to happen in the same time frame as 6G, but it's not linked to 6G in the sense of it needs a brand new 3GPP defined technology in order for us to become quantum safe. That's a nonsense. I think if we do start to think about brand new technologies that might be proposed in the 6G era, of course it would make sense for those to adopt the right cryptographic algorithms from the outset to make sure that they're taking steps to mitigate against the quantum threat.
Great, thanks for clarifying that, Luke. And as you say, this is something that NGMN is also looking at then. Second point that we identified here when we're looking through all those submissions is around the area of speed. There's not a lot of mention of top line speed with the proposals at this stage. It's much more about network simplicity and agility for service requirements, which seems a bit of a departure from what we've had before. Puneet, am I right in that assumption, and how might that impact telcos as they position future technology and services?
Yeah, thank you, Guy. Like in the previous question, you asked about learning from 5G, keeping it simple and focused, and making all important capabilities available from day one. So that speaks in itself directly to a broad evolution on how approach standardization of 6G. From a standards perspective, the development of 6G is likely to go some paradigm shift, not just technically, but also in governance, intent, and overarching purpose. With 5G, what we saw, the emphasis was largely on performance-driven KPIs, which was about peak throughputs, ultra-low latency, high reliability, and denser connectivity. Networks were designed and optimized primarily for traffic and devices. But with 6G, we are going to see a shift in standards development philosophy. The focus is moving from maximizing raw performance to build a purpose-driven networks, one that are human, machine, and society-centric from the grounds up. This means addressing goals like sustainability, digital inclusion, AI augmentation, sovereignty, and trust as a core design pillars, not afterthoughts. So the IMT 2030 vision of intelligent, sustainable, and ubiquitous connectivity captures this shift well. And that's why simplicity and focus on early standardization are so critical, because 6G isn't just about bigger and fatter anymore. It's about aligning networks with broader societal and planetary goals, getting those foundation capabilities, trust, energy efficiency, native AI supports, and global inclusivity into the day one standards will be essential to realizing the vision and also to avoiding the kind of fragmentation and retrofit challenges what we saw in 5G.
Thanks very much, Puneet. Luke, it does seem that priorities have shifted a bit this time, because as I said, we are so used to looking at ever faster speeds, and then for the operators or service providers to start marketing that as the reason for consumers and users to upgrade. It looks very different this time around. How might this change things, Luke?
Thank you. I think you raise a very valid point. I think we're reaching the end of the era where each successive generation has to be coupled with ever increasing but largely meaningless peak rates from a customer perspective. And in fact, if you look at what we're doing with 5G, or rather we look at what was specified in 5G, it already has higher peak rates specified than any operator has been able to deploy in a meaningful way, because we don't have the spectrum assets to reach those speeds anyway. So to then develop a brand new technology that aspires to push those speeds even higher, in even higher frequency bands, really doesn't make a great deal of sense. So I'm very pleased to see that there is far less emphasis on speed, or more emphasis on trying to see what do we need to do to innovate around areas that can make a difference to people, or to the ease with which and the operational efficiency that we can operate networks through. So I think it's very natural for me to see less emphasis on speed, more emphasis around how do we meaningfully reduce the cost of operation, the cost of ownership. As operators, how do we drive high return on capital invested in a way that allows us to continue to invest in infrastructure to the benefits of the customers and the digital societies that we serve. So I think it's important to bear that in mind as we look at the technologies that might be proposed for 6G, and make sure that those are very well benchmarked against what we could do anyway with the right investment, using the technology that's already specified. And we don't artificially create some driver for a new technology that doesn't actually do a great deal more than the old technology.
Yeah, thanks very much, Luke. And Diana, let's come across to you. This move away from the theoretical peak limits that we've been so used to. What do you make of that, and how might it change the work that the RAN groups do in 3GPP, for instance?
Yeah, I mean, I agree with the previous speakers, so I'll try to not repeat what they said. One key thing that will drive some of the RAN design and consideration is also the idea of focusing on quality of experience rather than just peak throughput. And this is basically focusing on the perceived user experience or user throughput throughout the connection. And this means that we want a persistent and consistent experience at cell edge. We want a good, consistent experience at during congested time. And this also means that we need to improve coverage, right? To make sure that the experience remains consistent throughout the whole cell. So this is one of the things that will drive a little bit some of our RAN decisions, and especially the user plane layer 2 design, because now we need to tailor for new services like immersive services or Gen AI, conversational Gen AI that has strict end-to-end 1 second delays. We need to have a system that deals with intermittent data, bursty data traffic, delay bound traffic. And to do all of this, we basically need to rethink the user plane design that we could not do in 5G. We pretty much kind of used the same baseline as 4G, and now it's time to rethink things and build things from the beginning with the right design requirements in mind.
Very interesting. Thanks, Diana. And let's come across to Dean. Dean, what do you make of this shift then?
I think it's long overdue. And I think that whether it was implicit or explicit, most, with the exception of vehicles, almost all the use cases that need high speed, let's not call it maximum, are when we're indoors, as all of us are right now. Whether it's video, whether it's gaming, whether it's education, healthcare, industrial automation, almost all of it is indoors, which essentially means that the conditions under which we might want peak performance, and whether that's throughput or latency, are likely to be the ones which are worst for higher frequency bands because they won't go through the wall or the window, and also the ones where we're most likely to be either on Wi-Fi or some other technology. And so whether it was explicit or implicit, I think there's a bit of a recognition here that there was a fundamental issue with 5G, in that peak speeds and also the mythical 1 millisecond latency, no one actually thought about where that had to be delivered rather than how.
It made for good press releases from certain quarters, though, Dean, didn't it? For a while, you could play off the companies against each other. It's interesting to see how this is shifting. And certainly I'm very pleased. Well, let's move on, because another key takeaway that we identified was NTN. I mean, there was almost universal calls for non-terrestrial network integration from day one, and there were a number of NTN players who made submissions to the workshop. And yet there's lengthy life cycles when we talk about satellites, a bit like industrial equipment. This might not sit well with the 10-year generational cycles. I mean, we're already here about the need to maintain equipment for a long time, and you can't very easily replace onboard satellite equipment without bringing the bird or decommissioning your bird. So I'm interested to know how this might play out. And Dean, can I come to you first? Because you mentioned earlier about this may go some way towards trying to achieve ubiquitous communications, which is a goal we've had for many generations now. So what do you think?
Well, there's a couple of things. I've got comments on satellite, but specifically on the ITU's sort of wheel diagram about what IMT 2030 IE6G should do. One of the bullet points, which I understand was quite hard fought over, was around ubiquitous connectivity. And really, there's two parts of that. One is the macro network, particularly rural areas or sea or aviation, which is very much in the NTN space of sort of remote coverage to reduce cost and improve connectivity for lots of different use cases. But actually, again, and I'm sorry to harp on this theme, is the other side of ubiquity is in building, in industrial settings, particularly if you want to do things like network slicing, it's at the moment you can't say have a contract which says, well, we'll give you a guarantee of throughput or latency, but it's not valid if you're in the basement or indoors or visiting a friend or inside a metal factory or something like that, unless you've got a dedicated system. And you then run into this challenge of offering public services on private property and how and who manages that. And you get into a world of complexity. And I was hoping that 6G was going to address some of the fundamental realities of that we need to sort of think of the indoor environment as really the primary place we use wireless. It's over 90% of wireless data is consumed indoors, whether that is on cellular or on Wi-Fi. A lot of that is sort of TV streaming, Netflix and that. But a lot of it is also for smartphones, for industrial equipment, for, well, as we're probably all doing now, laptops, and a whole class of IoT products. And I think that when we talk about ubiquity, satellite and NTN doesn't really have a say in that part of the market. The flip side, I would say, on satellite, and Guy, your comment about the life cycles, well, actually, the life of a LEO satellite is about 5 years before it drops out of orbit. And if you've got enough launch capacity as SpaceX and others do, you can keep refreshing them. And also, some of the high orbit satellites now, the MEOs and GEOs, are actually software reconfigurable. So you can update the software, if not the hardware. So I think that interestingly, there will be some instances where there are going to be, particularly for IoT and say things like defense and other sectors, we might have satellite primary connectivity where the terrestrial bit is the add-on rather than vice versa.
Okay, thanks very much, Dean. And good points about the satellite longevity and the software elements of that. I know there was a number of comments about being able to sort of go backwards in generations with satellites in the submissions. But we're going to hear a lot more about this in the coming years, I'm sure. Diana, I want to come across to you next, because non-terrestrial networks, covers more than satellites, doesn't it? It's anything that's off the ground. So what are your thoughts on how this might play into what becomes 6G?
So I think, first of all, it is important that we think of NTN design from the beginning when we're designing 6G. But I do think that we need to pay a bit special attention about how we do it, because we have to remember that we spend a lot of efforts for 5G, developing 5G NTN solutions. Over the last 3 releases, we've been working on 5G and RNTN. And if the satellite community, what I understand, there's intentions to already deploy 5G and RNTN and launch satellites with 5G NTN. Keeping this in mind, then we have to first think, okay, how can we design 6G services that can connect maybe to the 5G satellites that have been already launched? Or if we do enhancements, we need to make sure that they're only software upgradable. And then when we're looking at the RAN side of 6G, the question will be, do we specify yet another 6G NTN system from day one? Or do we just make sure that the 6G system is designed with the right hooks for 6G NTN to eventually be deployed once we get some understanding of real deployment problems from the system? And I'm saying that because if we define a full 6G NTN system in the RAN from day one, then this could actually delay the success of 5G NTN deployments. So these are things we need to consider and analyze carefully while we make sure that we enable the NTN to be integrated in the system from day one.
Thanks very much, Diana, for that. There is a lot to consider there, and all the while you're also looking at the need to keep things simple and reduce options. This is a very, very tricky problem to be involved in. Luke, let me come across to you. Have you got thoughts on the role of NTNs and how that might shape 6G?
I've certainly got thoughts on the roles of NTN. We see them very much as a complement to terrestrial network, whether that's as a complement D2D-wise, device to device, to supplement the terrestrial mobile network in areas that are unprofitable or very, very difficult to serve. Same thing for where you might have areas that is very difficult to reach with fiber, where you can connect a dish and provide some alternative to a home broadband connection using satellite. So in the 6G era, again, using that term very, very consciously, we see non-terrestrial networks as playing a very useful role for customers. I don't think there will ever be substitutional in a scale sense, either for fixed infrastructure or for mobile infrastructure, but they are certainly a very, very useful way and of high value to customers. We don't, however, see a strong dependency between our customers using non-terrestrial capabilities and what 3GPP develops as 6G. I think back to the mantra, keeping things simple, making sure that whatever gets proposed by 3GPP for 6G is measurably better than what could be achieved using 5G. The same thing holds for satellite. And just commenting very, very briefly, I think it was a comment made by Dean around the life cycle of the assets in orbit. I'd also like to add to that, there are different satellite architectures. Some of them put radio heads in space and the infrastructure, the baseband processing remains on the ground, which makes it very, very upgradable. And so it's starting to become a part of our connectivity fabric and part of what operators would deploy as they try and serve customers wherever they might be. But linking it very, very tightly to something that only arrives with the development of 6G, I think would be misleading.
Great, thanks for those points, Luke, much appreciated. Which brings me to, well, my final observation from these submissions, and that's around the area of AI native. AI is everywhere in those documents. There's a general acknowledgement that networks need to be built for AI, whatever that really means. How could this change future networks, and is it achievable? Diana, let me come across to you first. What are your thoughts on building out as a AI native?
So, Guy, this is a very interesting question because, like you said, AI native appears everywhere. The question is, what is AI native? Everybody has their own definition of AI native. To me, it basically means designing a system that natively supports deployments of models, supports automation for the RAN and the core network, and any other additional AI data-driven solutions. And the one thing that I feel AI can do is offer some monetization opportunities in the future. And to do this, and it's so to me, it's more about offering monetization opportunities, not necessarily redesigning the hardware or relooking at the fundamentals of the air interface. It's more about finding opportunities by offering new services, offering data collection framework, data exposure, computing services to offload terminals. These are the kind of things that I feel would be very important for the 6G system. And when we're looking at what can we do in 6G from the get-go, to me is having a unified framework for LCM, basically a unified framework for data collection, exposure, and model transfer. So this is what I think we need to focus. And then, of course, as we understand more the key different technologies, we can look at using AI as a tool to increase performance of some functionalities.
Great. Thanks for those insights, Diana. And Puneet, let's come across to you next. What were your observations on the discussions around AI native?
Yeah, thank you, guys. So, like building upon what Diana mentioned, right? So during the 6G workshop, what we saw the two categorization, in the various presentation, and actually every single presentation talked about AI. The one theme was about AI for 6G. This is about AI is a tool to make 6G better. And this refers to using AI technologies to enhance and optimize 6G network operations, performance, and management. So the example of this would be, using AI for network management and orchestration, using things like resource allocation, predictive maintenance, and anomaly detection. Also using AI for security threat detections and preventions in terms of QoS optimization and service personalizations. And these are the things which we have been also doing in 5G and 5G Advanced. We're basically using AI as a tool to make the 5G and 5G Advanced better, and same things will continue also for 6G system. And also this considers things like radio interface optimizations such as RS overhead reduction, channel estimation, modulation, AI-based receivers, protocol parameter adaptation, and things like that. And then there was other theme also which we have seen during the workshop, which is about 6G for AI, which is about 6G is a platform to enable AI. And this basically refers to designing 6G network to natively support and facilitate AI-driven applications, services, and use cases. So if you kind of look 6G system as a wide area network, then AI becomes a workload. And what I mean is, like, how can you move that workload efficiently within the 3GPP network from all the way from the data centers to clouds to basically core network to edge and all the way to the device. So basically, if AI is a workload, then 6G system can be provided as a capability to efficiently analyze those data and move this AI workload efficiently. Because one of the things which you get with 6G network is mobility and lower latency, and that can basically really optimize enablement of AI. Now, having said that, one thing which is also of importance is AI integration into 6G networks bring although remarkable opportunities, but it also faces a significant challenges. The traditional cellular networks are based on deterministic behavior, while AI-driven systems are probabilistic and adaptive in nature. So AI predictive behavior can introduce uncertainties which may have serious consequences in high reliable environments like communication system. And it is important to have non-AI algorithm as a fallback option when AI cannot deliver deterministic results. Furthermore, it is important to note that the performance of AI heavily depends upon the quality of data it uses. Error or incomplete data can lead to system failure, make data quality assurance and critical priority. So these are the things which we have to pay a very close attention as we integrate AI in 6G networks.
Yeah, thanks for that analysis, Puneet. Thank you very much. And Dean, let's come across to you for your thoughts on AI native.
I'm currently doing some work looking at this with a colleague on what the main cases for AI within 6G will be and what are the problems that it solves. But first off, I'll say that I'm going to strongly disagree. I think that 6G needs AI. AI does not need 6G. AI is evolving on its own very well and will have done through another 5 or possibly even 50 iterations by the time 6G arrives. The vast bulk of connectivity for AI is inside and between data centers. And if anything, the last mile, whether that's fixed or mobile, is becoming less important because the inferencing and the training is either done on hyperscale cloud or on device. So actually NPUs in phones, home gateways, and other things. If there was going to be a connectivity aspect to it, we'll see it first in the fixed world, not mobile as well. But looking at the how AI can improve 6G. I think that we're going to end up with two classes. There's going to be some horizontal uses of AI where we do need to have shared data models and sort of standardization, which is where you have multiple use cases that all use the same input data. But I think we'll also have siloed examples, which might be in the radio, it might be in the planning and design tools. It could be bits of the network where you've got a third party like a neutral host involved. So I think that we're going to have a combination of sort of a unified AI capability and then also diverse sort of point solutions here and there. And I think that if we try to sort of create one AI ring to rule them all, we'll probably end up wasting too much time and effort on that. But I really, one thing I just do not see the monetization aspect as being something we should be talking about at the moment. I think, again, some humility is needed. And by the time 6G emerges, we'll be in a world with AI everywhere. And 6G will need to fit into that. It won't be turning up late to the party with a cheap bottle of wine saying, "Hey, I'm here now." Now the party can get started because the party would have been going on for 10 years.
Yeah, thanks, Dean. Who knows what AI is going to look like in 5 months, let alone 5 years? Well, those were 4 takeaways and themes that we identified as part of our report series, but are there any other important ideas or requirements that have emerged at this time? Diana, let me come to you first.
No, actually, Dean, I was going to just talk about the multi-rad spectrum sharing and the importance of it for 6G design, because it also has some fundamental design consequences, meaning we need to design a 6G system that coexists in 5G spectrum with 5G devices and minimizes overhead. So I think this is going to be a very important consideration for 6G. And also maybe one other thing I didn't hear too much about was energy efficiency, Guy. I think that's also was a very repetitive message because it lowers the total cost of ownership for operators, and of course enables us to have a green 6G system. But given lack of time, I won't elaborate more on that. But I think it's an important aspect.
Diana, you're absolutely right. It certainly was. It was mentioned an awful lot. Energy efficiency. We didn't have time to mention it during our discussion today, but this is something we will be on top of and we'll hear a lot more about, as was cloud native. Okay, so I want to move on to a final question now, and I'd like to just identify what the actual next steps are. What are the timelines that we're working to? What does the industry need to do right now to prepare for 6G and to ensure that the specifications are exactly what it needs? Puneet, let me come across to you first. What are the next steps from the 3GPP?
Thank you. So 3GPP has basically decided that the study phase of 6G would be done as part of Release 20, and the normative and specification work will be undertaken as part of Release 21. In Release 20, we have going to have several studies. So one study which is about stage 1 use cases and service requirements has already been approved and already undergoing as part of 3GPP SA1 group. And the expectation is to complete the study on use cases and service requirement by March 2026. And on the RAN side, we have a single study, but with two phases, one on focusing on alignment with ITU's IMT 2030 framework, and the phase 2 part of that is focusing on generally on topics beyond IMT 2030, and that is expected to be complete by June 2026. Then what will we also start to see in June plenary this year is a studies on SA2, which is about system architecture, which also defines the going to define the 6G core network, or should I say core network for 6G, and that is expected to be approved around June this year at the Parag plenary. And that is going to set a stage for concrete technical work on architecture, and similar studies in RAN 1 and RAN 2 working groups also focusing on the physical layer as well as the layer 2 and above would also be expected to be approved by June this year. Now, the normative work will be undertaken in Release 21, and Release 21 is expected to produce a first set of 3GPP 6G technical specifications, and that would be a release for IMT 2030 submission before 2030. And we have not yet finalized the timeline for Release 21, but it is expected to be discussed, before June 2026. And the overall expectation is that the ASN and Open API freeze for Release 21 would be no earlier than March 2029. Now, in terms of what the industry need to do today and in near term to ensure 6G specifications are what operators and their partners truly need, the first and foremost is actively engaging in study phase is really, really critical. This is our window for opportunity to influence the direction of 6G, not just at technical level, but at a foundational level of use cases, service requirement, architecture, and protocol design. So all industry stakeholders, especially operator verticals, MRPs, must articulate clear priorities to avoid repeating the past issues like overly complex feature that was underutilized in 5G. Secondly, and this is also a really important point, is that we need a strong cross-industry coordination. So this coordination and collaboration across the industry is really important given all the geopolitics, so that 6G is not over-engineered, but instead focusing on the core capabilities that can be deployed efficiently and adopted widely from day one. And this collaboration is not just within 3GPP, but also going across the SDUs, especially working with ITUR, and also we ORAN Alliance to avoid any market fragmentation. And just on that point, basically, we also had a workshop along between 3GPP and ORAN Alliance last week at Sofia Antipolis to basically discuss some of this area of collaboration and work split among these two organizations.
Puneet, thank you very much for that. There's a lot of milestones there for us to hit. Thanks for going through and making that very clear to us. Dean, I'm going to come across to you next. We've been focusing today on 3GPP, but of course this is part of a wider, umbrella IMT 2030 process, or is it? So what are your thoughts?
I think there's a couple of things here. I think there's other things that are going on with 6G that are outside of the sort of mainstream 3GPP stream. So I was with some people from the Wi-Fi industry and IEEE over the last few days, and I've been trying I'll admit fairly unsuccessfully to say that there ought to be more than one candidate technology for IMT 2030. And I think that sort of something like Wi-Fi 9 or 802.11. Whatever it will be, ought to be targeted for official recognition as an IMT 6G technology in the same way that DECT is for 5G. I think that would be important for a number of reasons. But the other thing that I think from a timing point of view is we need to be very conscious of what I call path dependency effects of stuff which is happening both inside the industry but also outside, which has long-term ramifications, which we can sit around and academically think about what 6G might be when it emerges. But we have to keep an eye on the real world and what's changing. And obviously there's a ton of stuff around geopolitics, and there are going to be decisions that are made over the next, frankly, 3 to 6 months, whether it's on trade, whether it's in international organizations and bodies and how different parts of the world interact with them. GDP and economic developments may influence who gets to direct the future trajectory of 6G. But also there's a bit of an uncomfortable reality for the mobile industry at the moment in that data growth rates are flattening or in some cases even falling. And so 6G, the next few years are going to be some interesting challenges where we start thinking about potential structural change in the mobile industry, especially if we hit the barriers of either unprofitability or overcapacity on 5G, and what that does to 6G directions. Then there's other adjacencies of satellite, spectrum, World Radio Congress in 27, which at the moment looks like it'll either be in China or Rwanda, and how that fits geopolitically. So I think that we need to be conscious of the wider world into which 6G emerges.
Absolutely. Thank you very much for those comments, Dean. And Luke, I'd like to ask you really about NGMN's work, because we know 6G is one of the three, has been one of the three key pillars of your focus. Do you have timelines and milestones in your 6G activities?
We certainly have. We have outcomes in mind, I would say, more than timelines. So I think rather than focusing too much on what 3GPP may achieve by a certain period of time, or indeed any other technology, because from an operator perspective, I think competition of technology proposals is generally good and to be welcomed, and it generally makes people raise their game. But if we can achieve something that's meaningful and allows us to deliver a better experience to customers in the time frame that's been allowed for 3GPP to do its work, then fine. Within NGMN, we've defined something called the Radio Performance Assessment Framework, which we published a few months ago, and it's intended to allow technology companies bringing new proposals into the standards, whichever standards they may be, a way to benchmark the real benefits of whatever great new widget they're bringing to the party. We've seen attempts in the early stages of this process for people to come with a brand new idea, say, look, this is way better than you guys have already, only to find that they benchmarked it against the very first release 15 version of 3GPP 5G, rather than something that reflects all of the fantastic work that 3GPP has done in the intervening years. So you should really be comparing it with something like release 18, where you look at the advanced features that have been developed and then say, well, what could we do to meaningfully add some performance on top? And then we can see, okay, that might fit into some of our future investment plans. But being driven by a relatively arbitrary deadline set by the ITU and then being acted on by 3GPP, that presupposes that we're going to build an investment case for some brand new technology simply because it exists, that isn't going to happen. So I think if you look at some of the board level guidance that's come from NGMN, we talk about the importance of retaining global standards. Of course, we want to make sure that we avoid fragmentation where possible, that things remain interoperable, that we have the right commercial scale behind technology to make it investable in, and that we see as much of a focus as possible on making things software upgradable rather than requiring brand new hardware. So again, this is so that we can make whatever technology innovations come through the pipeline something in which we can invest for the benefits of customers. So we're very, and this is a view that's shared broadly across the NGMN operators, we don't want to be driven by some external factor that demands that we start to deploy a new G. We want technology providers to continue to innovate, continue to give us more cost efficient, more energy efficient technologies, simpler to operate, that we can gradually seed into our networks in a way that makes customer experience better and allows us to invest for the benefit of all of the industries that we serve. And I agree with Dean, we talk about verticals in an offhand way. I don't think we want to do that in the same manner this time around. I think we need to build an extensible technology that allows us to address as many opportunities as we can from wherever they occur.
Luke, that's a great place to end our discussion. Thank you very much for those comments, but we do have to leave it there. We've covered a lot of ground. There's a lot more ground we could have covered. This is shaping up to be a very interesting start to what will become 6G. So thank you all so much for taking part today. We will, of course, be expanding our coverage on the preparations for 6G. We've got a session at the DSP Leaders World Forum event next month, and there will be additional editorial content throughout the year on our 6G channel. And don't forget to download our report series on defining 6G networks. All 4 reports are now published, and links are on the TelecomTV website, and we'll also add them below this video. For now though, thank you so much for watching, and goodbye.